division of radical expressions. And still, we are going to look at what is the fundamental rule of the division of radical expressions. We have radical A. Okay, now it is divided by another radical expression. And what is the rule? It's very similar to the multiplication. So we still need just have one radical symbol and then use the numerator radicand divide by denominator radicand. All right, so we turned two radical expressions into one radical expression. The only thing we need to do now, again, we need to simplify this radical expression. And remember, there is a rule. It's pretty similar as any fractions. So we know this default thing for any fractions, it need to be simplified. Same thing here. For any radical expression, it need to simplify. So the simplification means we move the radicands out as much as possible. And there is another requirement here. No denominator is allowed in the radical symbol. So another word here, if we see a denominator here, it cannot stay inside and it has to go outside. So this is to simplify a radical expression. When we see a fraction inside of it, not only we can move everything as much as move the factor out as much as possible, there is a second requirement. We cannot keep the denominator within the radicand here. Okay, but how can we make this happen? Let's look at this a little bit different from the multiplication. So division is a little bit harder. And let's look at this one. So if I have radical 6 divided by radical 2. Oh, this is the simplest case. Apply the rule directly. I have the division of two radical expressions. Then what do? I just divide the two radicands. 6 divided by 2. And we all know that 6 divided by 2, what does this equal to? This equals 3. Okay, radical 3. Can we continue to simplify it? No. Then that will be the final answer. Okay, so that is the simplest case. Now, if I give you another one, if I have radical 2 over radical 6, okay, still the division. Apply the rule again. What do we have? We'll still have this radical symbol and then divide the two radicand, 2 over 6. Okay, and we know for this for this fraction, 2 over 6, we all know it equals 1 over 3. Okay, so can we leave the answer here? The answer is no. This can never be the final answer. Why? Because no radical expression can have a denominator inside, or no denominator is allowed to stay inside. So we have 3 here. See, 3 cannot stay inside. If it cannot stay inside, it means we have to move it outside. But we cannot just move it. We have to follow the rule. The rule tells us one can move something out of the radical symbol when it has a square, when it has the exponent 2, then we can move it out. But this 3, its exponent is 1. So we want to move 3 out, but we cannot now. One can move this out. If I have a square here, I will be able to move 3 out. How can I get the square here? If I multiply another 3. So if I have another 3, 3 times 3, then I have 3 squared. This 3 will be moved out. And recall, we have done this so many times. This is the equivalent symbol. We cannot change the expression. So whatever we do to the denominator, we should do the same thing to the numerator. So if we multiply 3 on the bottom, we should do the same thing on the top. So 1 times 3 as well. Now, so they're still equivalent, right? I didn't actually change the value. I just changed the looking. Both the denominator and numerator multiplied by 3. They'll still remain the same. But now let's see, I'll rewrite it. What do we have now? I have 1 times 3 on the top. I have 3 times 3, that's 3 squared on the bottom. Now, can we move the 3 out? The answer is yes. And as we said before, when we move a denominator out, it will still stay on the denominator. So this 3 will still under the bar. We have 3 here, and nothing is left. Is numerator 3 will stay inside. So that will be 1 over 3, and this 3 stays inside. So we will write this as 1/3 times radical 3. Or if you want, you can also write this as radical 3 over 3. So those two expressions, they are equivalent. They're both correct. But normally we prefer write the second way out. So when we move 3 out, it stays on the bottom. So this radical bar, this is the bar here, and 3 stays on the bottom, and this 3 stays on the top, but it is within the radical symbol. And this is the final answer. All right, so to divide two radical expressions, we just divide the radicands, but then we have to simplify the radicands. Not only we should move as many factors as possible, and remember, we cannot leave the denominator inside. If the denominator cannot be moved out directly, what do? Multiply by itself. Then do the same thing to the numerator. When we multiply by itself, we'll have a square. When we have a square, then we can move it out. Okay, so this is the first type of division. Single term radical expression divided by another single term radical expression. And what do? Just divide the radicands and then move and simplify it. In one word, simplify it. Let's look at a few more examples right here. Okay, see what we have here. I have this one. So we have seen numbers. What if we have variables? Same thing. Okay, actually, so this one here, we don't have to divide. We just need to simplify this radical expression. What do we have? We have radical, okay, c to the 9th over c to the 3rd. Using the exponential notation rule. Same base. When we divide, we'll keep the base, we subtract the exponent. So 9 minus 3, we have 6 here. So we get radical c to the 6th. And 6 is an even number. Then we know c can be moved out because it has an even number exponent. And this new exponent will be half of the old exponent. 6 divided by 2, that's 3. Okay, so that will be the final answer. So this one looks pretty similar. And if, now I'll give you another one. So what if we have another example? We have radical 11 over radical x. So what does this equal to? This equals radical 11 over x. So write down the division directly. Apply the division rule, numerator divided by the denominator. And then we know we want to simplify this radical expression. And we also need to move the denominator out. What do we have here? We have x. If we want to move x out, we're supposed to have another x. So multiply by itself. whatever we do to the denominator, do the same thing to the numerator, times x as well. Because we have 2x now, x times x. So this 2x does not mean x plus x. It means x times x. Then we'll have x squared. So this x can be moved out, but it stays on the bottom. We have draw a bar here, and we'll have x. What is on the top? We have 11 times x. 11 is a prime number, and we cannot factor it. The power is 1. This x has the power 1 as well. So both 11 and x, they'll stay within the radicand. Okay, so this radicand is for the numerator part only. And those x times x is moved out, is not included. So you can write the answer in this way, or if you don't like this, you can write this as 1 over x times radical 11x. Either expression is correct. How do we deal with that? We just, multiply another one. All right, so now let's look at another example. What we have here, we have, radical w over 52. And so you'll say, okay, and we know that 52 is not, there, we cannot move 52 out. So what should we multiply? Should we multiply by 52 directly? So no. And for this one here, we have w here, factor 52 out first. So 52 equals what? 226. And 26 equals 2 times 13. So the denominator is 2 times 2 times 13. So instead of multiplying the 52, and we can only need to multiply by 13, then we can turn the denominator into a perfect square because we have 2 2's already. We only need another 13. Whatever we do to the denominator, do the same thing to the numerator, times 13 as well. And now you know what we can do. We can move the 2 out. We can move the 13 out. 2 times 13, that's 26. It's on the bottom. What is on the top? Radical 13w. Switch the order. Number is always in front of the symbol. So this example tells us what? If we have a number on the denominator, do not rush to multiply the number. And we have to factor the number first, then multiply the smallest number. Then turn the denominator into a perfect square. If we do not multiply by the smallest number, and we will have to simplify the fraction later. And that will involve a lot of more steps. So no rush. All right. So if we have a number, always factor it. And what I want to do now, I want you look at a more complicated example like this. It looks more complicated, but it's not here. So we have a radical, a fraction inside. And let's see, what can we move out? So 121 is 11 squared. So then 121 can be moved out, turns into 11. And m to the 10th, when we move this out, turns to m to the 5th. And they are on the top of the bar. They belong to the numerator. Then we look at the denominator, n to the 4th. It happens to have an even exponent. So this n to the 4th, the whole denominator can be moved out, turn into n to the 2nd. Final answer. Okay, so I think that's the example I want to show you for now. This is the first type of division. Single, we can treat this a monomial over monomial. The next one, the problem will be a little bit more complicated. If we have a polynomial divided by a monomial. For example, if I have radical 6 plus radical 2 over what? Over radical 2. So the numerator is a multiple term radical expression divided by a single term radical expression. What do we do? Distributive law. So the first term, so it turns into radical 6 over radical 2 and plus radical 2 over radical 2. So every term of the numerator will be divided by this single denominator. It's like the distributive law. Then we work on each, so each division turns into the simplest one, monomial over monomial. So that will be radical 6 divided by 2, 3. And then radical 2 over radical 2 equals what? Equals 1. Okay, and you might say, Professor, can I write this? I know radical 2 over radical 2, that's what equals radical 2 over 2, that's equal to radical 1. And radical 1 can be simplified because 1 equals 1 squared. Raise any power to 1, it equals itself. So radical 1 is always equals 1 itself. So do not keep the radical symbol around number 1. This radical symbol should be removed. Okay, so this will be the final answer. If we have, okay, one more example here. One more example. If I have this, so I have still polynomial over monomial. What does this equal to? It equals 6 over radical n and then minus radical m over radical n. So we can use the distributive law. And then what do? We are going to simplify each one of them. Okay, this is interesting here. So this 6 is not within the symbol. All right, so how do we deal with this one? Okay, so this is a very interesting problem. What if we have, I will copy the problem down here, 6 over radical n. So what do we do? The general rule tells us if we have radical over radical, and then we are going to just keep the radical symbol, use the denominator, numerator over denominator. This general rule. But for this one, 6, it's not within the radical symbol. Then what do we do? Okay, so there is another way to interpret the problem. So what do we want? We have this fractional notation, something like the rational expression. We do not want to have the radical symbol on the denominator. So remember my words here. I said the radical expression cannot have a denominator. And the second one here, we'll see the denominator cannot have a radical expression here. So how can we get rid of the radical expression on the denominator? If I have another radical expression, I multiply the radical expression by itself. We know how can we get rid of the radical expression if we raise a power. Those two will cancel each other. What does it mean to raise a square, a power of 2? Multiply by itself. So if I have this one, radical n times radical n, then the numerator should times radical n as well. Now let's see those two are supposed to be able to cancel each other. That's why we know they're equivalent. But after we multiply this radicand expression on both numerator and denominator, what happened? The denominator, radical n times radical n, turns into what? Turns into n. And the numerator, 6 times radical n, will remain the same. This will be the final answer. Okay, very interesting now. So what I'm going to do now, when we have this special division here, when the denominator is a single term radical expression, so we could use the distributive law. Okay, so look at, we can use the, and then simplify each one. Or, okay, there is another way to treat this division here. So I will copy the problem here, and radical 6 plus radical 2, I don't care about the numerator, and divide by radical 2. So what I want, treat the whole thing as a rational expression. What I want, I just want to get rid of this radical symbol on the denominator. How can I make this happen? I will multiply by itself. So times what? Times another radical 2. So times radical 2. So the numerator, radical 6 plus radical 2, should also multiply by radical 2. So radical 2, they cancel each other. They're supposed to be same. Now let's simplify this. So I will turn this, the 2 multiplication respectively. On the denominator, it turns into 2. On the numerator, we go back to the multiplication. How do we multiply the 2 radical expression? Radical 6 times radical 2, we have done this before. It equals radical 12 to radical 3. And then plus radical 2 times radical 2, that's 2. But we have, for any rational expression, we have to simplify it. So everything divided by 2, that's radical 3. Those 2 cancel out. And 2 over 2, that's 1. See, we get the same answer. So either way, so you could use the distributive law, or you can see, I want to get rid of, so from another point of view, treat this entire thing as one rational expression. What we want, so we do not treat this as a division. We look this as a rational expression. And what we want to do, we want to get rid of the radical symbol from the denominator. How? If we have one radical expression, just multiply by itself. See, those are the 2 ways. One is just direct divide. And this one, treat this to get rid of the radical symbol from the denominator. So this method here is actually has a very special name mathematically. It is called rationalize the denominator method. So rationalize the denominator means what? Means to get rid of the radical symbol from the denominator. Okay, see what we are going to do next. Let me give you one problem here. So what we have here, so we can see, oh, this is a radical. This is a radical division. So something divided by another radical expression. But I will look at this problem from another way. I will treat this as a rational expression, but I want to rationalize the denominator. How does it mean to rationalize the denominator? I want to get rid of the radical symbols from the denominator. But there are 2 radical symbols on the denominator. How can I get rid of the radical symbol if we have a 2-term radical expression? Now we are going to use what we mentioned in the first section of today's class. Look for the conjugate of the radical expression. So instead of multiplying itself, if we multiply by itself, we won't get rid of both radical symbol. So what we are going to do, we are going to, okay, I will write this down, draw a long bar here to get rid of the 2 radical symbol from the denominator, okay? I'm going to look for its conjugate, then multiply by its conjugate. So this conjugate is what? If this addition, get subtraction between the 2 terms, radical 12. This is the conjugate of it. So multiply by the conjugate of the denominator. Whatever we do to the numerator, do the same thing to the denominator. So 7 should also times radical 3 minus radical 12. Okay, so after we multiply the conjugate on the top and bottom respectively, to look at what we have on the denominator. Radical 3 plus radical 12, radical 3 minus radical 12. Some time difference, that will be square minus squared. So square of the first term, that's 3 minus 12. And the numerator is 7 radical 3 minus radical 12. And simplify this, we'll get 3 minus 12 is negative 9. So negative 9, 7, parentheses. Okay, so this problem is very special here because radical 12 can be simplified. So I'll keep this down. So normally, if those two radicals terms, they are not similar, then we can stop here. But this one, radical 12 is actually equal to what? 2 radical 3. So radical 3 minus 2 radical 3 equals negative radical 3. So negative, negative, simplify. The final answer will be 7 radical 3 over 9. This is the final answer. And this problem is not very, very typical. Look at this one. I like this one better to use the rationalized method. What do we have? 2 radical symbols, all right? And there's 2 terms. The only way to get rid of the radical symbol from a 2-term radical expression is what? Is to multiply by its conjugate. So radical 3 plus radical d. Multiply by its conjugate is what? Radical 3 minus radical d. Then the numerator do the same thing. C times radical 3 minus radical d. Carry out the multiplication. What is on the bottom? Sum times difference. We'll get squared of the radical. So you do not write 9 here. It's the square of radical 3. That will be 3 only. 3 minus, so radical d squared equals what? Equals this 3 minus d. That will be the denominator. The numerator, you just keep this the same. If you want, you can move, carry the multiplication out or leave this here. That will be the final answer. Or you carry the multiplication out. If you can simplify, you should multiply, but this one cannot be simplified. You can leave this problem, the answer like this. So this is the division. So recall what we did today for the division. The division, if we have a single term radical expression, just divide the 2 radicand. When we have multiple terms, either on the top or on the bottom, we can treat this as a problem. So do not call this division problem. We call this to rationalize the radical expression. If we have multiple terms on the top, and we just multiply by the entire denominator. Okay, because there's just one radical expression, one term. If we have multiple terms and we are not going very far, and the most complicated problem, there will be 2 terms only on the denominator. Then we just multiply by the conjugate of the denominator. We can simplify this expression, follow the rules we had before, and then get the final answer. This is the division. It's a very, very special problem. Okay, one very last example. You can rationalize the denominator, or in another word, divide the 2 rational expressions. They mean the same thing. So that's called rationalize the denominator. What do? We look for the conjugate. So 3, 8 minus radical 5. Then multiply the conjugate 8 plus radical 5. And that will be 8 plus radical 5 as well. Then look at the denominator. 8 squared, that's 64, minus radical 5 squared, that's 5. Okay, I skipped one step. I did the calculation in my mind. Squared of the first term minus square of the second term. And the numerator now, that will be 3 times 8 plus radical 5. 64 minus 5 equals what? Equals 59. And then if you want, you can just leave this here, or you can say 24 plus 3 radical 5. Carry the multiplication out. That will be the final answer. Okay, so that will be the last example I want to share with you today. And okay, so that's all for the section 8.3. It's a pretty challenging section. So for the whole week, I just give you this only section. So normally we move 2 sections a week, but this is a special week. There is only 1 section for this week.